So good evening. This is the third day of application systems of equations. We're going to do, third day of systems of equations. Today we're going to talk about applications. How do you work these into an application? So let's look at this. First of all is in course pack, page 301. Get out your course pack, turn to page 301. These are your exact notes on this page. And go ahead and pause and get that. Okay, so now that you're back from getting course pack page 301, let's look at example 1. Pete and Willie signed their autographs to a total of 57 baseballs. Pete charged $5 per autograph, while Greedy Willie charged $8. Together they brought in $393. How many baseballs did each one autograph? So realize that's the question I need to answer. How many baseballs did each one of them autograph? So let's go ahead and set up our variables. X, what's X going to be? X is going to be the number of baseballs autographed. There's no accent on that. Number of baseballs autographed by Pete. You could call it P if you really wanted to, but X is what we usually do. Y is the number of baseballs autographed by Greedy Willie. We're just going to say Willie. So I think they're both greedy because who charges for an autograph? But anyways, set up two equations. So realize in this problem, I'm given two totals. I'm given a total number of baseballs and a total amount of money. Since I have those two totals, I can set up my equations based off of that. Total number of baseballs are the baseballs that Pete signed plus the baseballs that Willie signed. And that's going to be the total number of baseballs. There's no other baseballs. That's not going to be missing any baseballs. So that's my first equation. My second equation is a total amount of money collected. Again, my total is $393. Well, how did they make money? Well, Pete got $5 per autograph, and Willie got $8 per autograph. Those are my two equations. Again, I looked and found I had two totals, so I set up my equations equal to those totals. The total number of baseballs, the total amount of money. At this point, let's go ahead and solve my equations. If I look at this, to me, it seems easiest to use substitution. So I'm going to say that x plus y is equal to 57. I'm going to subtract y to both sides, so that x is equal to negative y plus 57. I'm going to substitute that into my other equation. So 5 times negative y plus 57 plus 8y is equal to 393. I'm going to distribute that 5. Negative 5y plus. Okay, so now I have to multiply 5 times 57, and I get 285 plus 8y is equal to 393. Combine like terms. Negative 5y and 8y is 3y plus 285 is equal to 393. That's a 393. Okay? So let's go ahead and subtract 285 from both sides. I get 3y is equal to 393 minus 285. I get 108. Divide both sides by 3. Y is equal to 36. So that tells me that Willie signed 36 baseballs. That's the first part of my equation. Now I need to find out how many Pete signed. So I'm going to come back to here and plug in 36 for y. So x is equal to negative 36 plus 57. It's a negative y, so it's a negative 36. So then x is equal to 21. So that tells me that Pete signed 21 baseballs. And those are my two answers. I need them both. I need to know how many balls that Willie signed and how many balls that Pete signed. That's a word problem. Again, the hardest part was deciding how to set up the word problem, and I did that by looking for my totals. A total was what I set the two equations equal to, and then I had to decide what the variables were. So then I had X was the number of balls that Pete signed, Y was the number of balls that Willie signed, and at that point, it was just a system that I had to solve, and so I solved it. Let's try my next example. Next example says, Lauren's marble jar contains marbles, plain marbles, and colored marbles. I'm going to move this down. If there are 32 more plain marbles than colored marbles, and there are 181 marbles in the jar, how many colored marbles are there? So realize what they give us in this problem. I do have a total, 181 marbles in the jar, but my other equation is telling me there are 32 more plain marbles than colored marbles. That's going to be my second equation. So first of all, I have to decide what are my variables. X is the number of plain marbles. Y is the number of colored marbles. Okay? My first equation is telling me the total. So I know my total is 180. Plain marbles plus colored marbles are 180 marbles. But now I have a relationship among, or between, I should say, the two kinds of marbles. This is telling me that there are 32 more plain marbles than colored marbles. So my plain marbles there are 32 more of them than the colored marbles. I take the number of colored, I add 32, and that's going to give me the number of plain marbles. I could also say so I already made a mistake on here. Let's go ahead and erase this one equation and try it one more time. There are 32 more plain marbles than colored marbles. My plain marbles are X, and there are 32 more of those than there are colored. So my equation should be X is equal to 32 plus Y. I had gotten the colored and plain mixed up in my head. The number of plain is equal to 32 more than my colored. So X is equal to 32 plus Y. I can also think about saying that if I have the number of plain, I can subtract 32 to get the number of colored. Either of these two equations are going to work. It doesn't matter which one I choose, but don't get your variables mixed up the way that I did. X is plain, Y is colored. So the number of colored plus 32 equals the number of plain. Or if I start with the number of plain minus 32, give me the number of colored. Make sure that you get that straight when you set up your equation. So now I'm going to go ahead, and again, I'm going to use substitution because I know what X is equal to. So I'm going to say, well, X is equal to 32 plus Y. So I'm going to plug this into my first equation and say 32 plus Y plus Y, because this is the X and this is the Y. This is the Y. That's equal to 180. combine like terms. I don't need the parentheses, so I can just forget about them. And say y plus y is 2y plus 32 is equal to 180. Subtract 32 from both sides. So 2y is equal to, scratch that. So 2y is equal to 180 minus 32, 148. Divide by 2, y is equal to 74. So the number of colored marbles is 74. So I can say there are 74 colored marbles. Okay, how many plain are there? Well, I'm going to come back to this equation right here, and I'm going to say, well, the number of plain is equal to 32 plus the number of colored, which is 74. So then x is going to equal 106. So there are 106 plain marbles. Remember, I give you a word problem. I give you a question in words. You need to give me an answer in words. So my answer is actually these two statements together, telling me how many plain and how many colored. The numbers are nice, but words are better than numbers when it comes to word problems. Make sure you give an answer in words. So again, the first equation, the first set of problems we had, I was given two totals. So my answers dealt with totals. The second equation that I had a total and then I had a relationship. And I had it set up my equations based off that total and that relationship. Okay, that's the work for today. I will see, for this evening. I will see you tomorrow in class. Bye-bye.